want to emphasize I am just the lead of this group, but all of these wonderful people have done so much of this technical work that you're going to see. So, hey, it's really a team effort, and we've worked actually, like Julia said, over 3 years and finally pulling it together, getting it approved, reviewing it, putting together this data report that we're going to talk about and this overview we're going to share today. So I'm going to go to the first slide.
You want me to share, Jeff?
Yes, please.
Okay.
So on the first slide, this is just our introductory. I'm just going to make a couple of points. Of course, welcome. Once again, this will be about a baker's dozen of slides that I'm going to quickly provide and give you an overview of what we're calling the C data warehouse. And that's going to be followed by a panel discussion. So I'm going to go through these slides quickly to give you a basic understanding, foundation, but they're really going to have some questions and answers, some that we've developed to have a good discussion and share with you. But we really encourage you, as I'm going through these slides and even through that discussion that we'll have, please provide questions that you have into the chat. So let's go. So slide number 2, and we're going to do an overview with you. And 3 major points I'll bring out here that are covered here. One is that this is based upon there's a need for data because planning, tracking, and the pursuit of quality are guesses if we don't have the data to give us the way of knowing where we are. It's like trying to go somewhere and I don't have a map, so I can't know. Or I have a map, but I have no clue as to where I've come from. Any different aspects like that. There's some sub-bullets there, but here's what the data warehouse is. It includes these 6 components. The rest of these slides will just give you the next level down, but this is what I'm telling you just in a quick glimpse of what we're going to go through in these slides in just the first 15, 20 minutes before we go to that discussion. Finally, note that the C data warehouse that we're talking to you about is free. Whether you choose to join us, and joining us means that we're just going to update you on a monthly basis about the presentations that we do throughout the year that Julia talked about and so forth, but it's available to everybody. We just we'll talk about, you sign in, you want to download this data. Once you have an understanding of what I can do with it, which we're going to give you today or get started on, it's totally accessible to the world. Let's go to slide 3 and talk about what's the challenge that we've seen for literally decades in software engineering. And really, these graphs and the words are telling you these basic things, and that is traditional, intuitive software development. Sometimes we've called it hacking in the past, other things, but it's really led to a lot of unfortunate delays, cost overruns, and a lot of quality issues. And typically what we mean by quality issues are we didn't build it correctly, and therefore we did a lot of rework and ended up blowing the schedules that we had often in our heads about how long something was going to take. What this is leading toward from this challenge is going to a data-driven world where we have modern methods and processes, which have actually been around for about the last 2 or 3 decades themselves, including, as you'll see, where this data came from that I'll talk about in a moment. But this requires a lot of data in order for them to be successful. And that's what the data warehouse is all about, is finally giving you a great start on a lot of data that we'll go into in just a little more detail. Let's look at the next slide and talk about, this is our solution, therefore, a data warehouse. And the data warehouse solution, it's really these 3 major components that we're conveying to you here. It's based upon actual collected data. The methodology that was used by a lot of people around the world came from what was developed by Watts Humphrey at the SCI, that a lot of us connected with, became teachers and coaches of, but that's where this data originally came from. However, It's applicable to many methods and different approaches. Different Scrum methods and so forth can take advantage of this data and just go really forward in from traditional intuitive to a data-driven way of planning, tracking, and providing quality. It's authentic data. It's collected literally by thousands of engineers across hundreds of projects or cycles of projects. And then finally, as Julia mentioned, this was data collected by the Software Engineering Institute over more than 2 decades, I believe. And SEI, fortunately, with our connection to them, agreed to hand that over to the C, trusting us to share it with the world. And we'll talk in one of the other slides about what the aspects of that is that we're providing in terms of trustworthiness and other aspects. But we're going to make this data available. Furthermore, what you'll see is that we're going to want you to provide more of this data and have everybody in the world join this effort and keep building up this database. So let's get into the foundations of what's in here on the next slide. So it's really based upon these 4 basic measures in 2 ways. It's plan data, and then when we complete the tasks that the data is associated, we collect the actual data associated with. And it's in these 4 areas. How long did something take, task time in getting it completed? How big was the product when we completed it? When did we get it done? Now you'll note that we use this process on ourselves, and there it is, 22 April of this year is circled because here we are, yay, finally. We're delivering this to the world and telling you about it. We're excited. And then finally, mistakes in terms of what kind of mistakes were made, how long it took to fix them, what cycle or phase or step were they injected, removed, and so forth. That's going to lead to the metrics that we'll talk about on the next slide. And so this foundational data in these 4 areas, planned and actual, is what provides on next slide. Yeah, there you go. These metrics in these 3 major aspects, the processes that we use and the metrics associated with them are based on planned and actual data. And how do we enforce, or not enforce, rather, increase the performance of those processes? There's metrics here for that. There's the basic planning metrics that are associated with a standard project where we plan the work, we work the plan, collecting the data throughout. When we're done, we're looking at how do we perform, and throughout all of that, we're looking for quality metrics. Quality metrics go back to those 4 basics I told you about. Time that we spent, and in this case, associated with mistakes or defects that we found, and then looking at what 2 different kinds of mistakes cost us, and what do we do about it in terms of process, and finding them faster, earlier, so that they cost us less in the overall end. So looking at the next slide, we're looking at data. Looking at the next slide, we want to go into just a level of detail down in the cost of quality side. And in these 4 areas, the true cost of what we call quality is typically it's an appraisal time. Those are steps in a process typically associated with finding mistakes that we've created in products that we built. How much time did we spend fixing the mistakes that we found? This is appraisal and failure, and often looking at relationships between those basic measurements and putting ratios together gives us insight into how much performance is affected. Performance is the overall time doing all of the work, but looking at these subsets of that data gives us that cost of quality insight. Plus, when we see things like appraisal time goes up, therefore failure times goes down, performance total time actually reduces also. So we're putting out higher quality products with less time. And then we also look at aspects of how do we improve processes, so that we're looking at how do we change a process, knowing the data and having those insights so that we can do prevention, so that we don't make mistakes in the first place. So all of this data is important to all of these aspects of understanding cost of quality for those phases and for the overall work that's being done. Next is how do we apply the data from theory to practice? And really what we're looking at here is different aspects, whether you're a developer, a researcher, etc., doing investigations. There's benchmarks that are put together, practices, estimations on typical projects, as I said, looking at the processes we've developed and how to improve those, decisions that are made, theories that are made. And it's really, this is really the important thing to emphasize here. It's planned versus actual of these basic measures that give us insights into how we're doing and how do we do something about it in the future. It's granular data and it allows all of those to happen at that sub-process level, step by step. So that's what's really important here. And like I said, just doing a quick overview, let's go to slide 9 and talk about what makes the data set unique. So the data sources come from these areas. Number one is these are coming, or this data has come from actual working engineers, not project managers, not people that made an estimate and said, here you go, project, and people on the project do it. These are the actual engineers themselves. They've collected the data, they've made the estimates, they're collecting the data, and this is what we're making available. It's come from projects, teams of those projects, supporting them, sometimes across many projects, the time periods that led to the performance analysis. The standard model across all of these, the third aspect, is really across different project types. It gives them ability to compare schedule, performance, and quality from different project views because it's the same basic set, data set that's unique but spread across all of these. And therefore, it's really a cross-industry relevant thing that we can do. So let's look at the next slide and talk about what it is the warehouse provides. And the content is really these 4 aspects. It's project aspects, as we mentioned. It's planned and it's actual. Those are the 2 aspects of data. What do we think based upon historical data and rates and other things, depending on which methodology and the words that you use. But so same ideas. And then how much time did I actually spend? How big did it actually turn out to be? How many defects did I think were going to happen? How many did I actually find and discover? What did those cost me? And which ones do I look for and change in terms of things like checklists that I look for those defects? All of those are based upon these kinds of data sets. So, and of course, the fourth major area that came from the basic measures I mentioned earlier are completion dates. This allows things like ability to look at plan versus actual, or earned value versus planned value. From an EVM point of view, earned value management perspective, it allows the cost of work to know what that insight is. So what the warehouse provides, we talked about, or we're talking about here now, and that's the project aspects, planned and actual, defects found, completion dates. So right, we mentioned that before. We repeated a couple of times because it's really important to understand these are the basic measures that contribute to all of this data set being available, useful, and how we break it up and turn into complex metrics. The way that it's distributed and made available, it's in a schema that was put together and sanitizes that data so we don't ever know by looking at the data whose data it was at an individual personal level, at an organizational project level, but we have good, useful data that's been sanitized in this common schema that we can look at all of these with. So the end point of that is that, and we'll talk about this, we'll give this to you today, but you can load this data, you can reload this data, and create your own private copy, local copy of that warehouse. And then you can start doing the analysis and different kinds of ways of analyzing the data and see what's telling you for your application on the kind of work you're doing in your organization for the project that you're doing. So let's go to the next slide and talk about, so we, the Software Excellence Alliance, how do we fit into this? As was mentioned, the Software Engineering Institute spent more than a couple of decades collecting this data. They've given it to us as a trusted source or steward of this data. And so here's the details of the different aspects of what it is we're trusted to be. We're putting our best in for the integrity aspect, to have confidence in the data. It's robust data. It's very granular, as I said. It's dependable. And as I mentioned, it's protected. Nobody's identification is associated with. We've taken that out so that people can use this data and not get caught up on whose data it is. And so this gives you some some insight into, in the future, when you contribute your data to this set, it's not going to be with your name on it. It's going to go into the general population of this growing data set that we're putting in place now. So let's see. Open access, we talked about, or we'll talk about, it is based upon SEI gave us this data, and this is going out to the world as a Creative Commons attribution license. That means when you download the data, all you do is say, here's where I got the data from, and now I'm using it. It doesn't cost anything. It's just a way of attributing where the data comes from, what its pedigree is, where it came from. There are no barriers involved, so like I said, it's free, it's easy to get. You can download it, and future sources of information and knowledge we may provide are ideas that we can provide the world about how to use that data, how to apply it. Our discussion panel is going to get into some of that for you here shortly, just to start to give you some insight into how that happens. So let's go to the conclusion slide. So really, here's just here's what we told you, just summed up at the end here, that it's about major advancement in these four aspects of what the data is for our community. So we're asking you to join the movement. What does that mean? Listen to this, become excited about wanting to use it, download it. And to do that, get started. Here's the website that you'll go to. Website will have you do a couple of simple things. This is who I am. I'm downloading the data. I'm the source for possibly more data in the future. So with that in mind, there's one more slide that has all of our emails on it. And so there we are, contactable. Of course, as you know, this is recorded. You can grab this later. But let's now, as I said on the previous slide, let's jump over to the C panel, where Julia is now going to go through a set of starting questions, but we look forward to your questions in the chat as well. So thank you. I think
Please feel free to put any questions that you might have in the chat. But I'll go ahead and get us started. So this one's to Bill Nichols. Bill is representing the academic view of the data, but Jeff mentioned several times that this data came from the SEI, was collected over years and years. Where did it actually come from? Can you give us more detail about that?
All right. The data came from practitioners, industry, government, few in academia, but from a variety of different sources and different industries. So we didn't create the data, but we did gather it. So some of the data was gathered by SEI coaches, TSP coaches. Some of this was gathered by the coaches we mentored. But all the data was sent to the SEI for collection and for future research. It's taken us a while to get this into a presentable state where we could actually start using it for that purpose. And that's kind of why we're here today.
Awesome. Thank you so much. So, David, this question is to you. You're representing David Tuma, representing sort of the tool view. So, how can we be assured that, how do you make this data useful but also anonymize it? How do we know that what does it mean to sanitize it? What information is available? What information is not?
Great question. So the data that uh, obviously that individuals collected to manage their projects was very rich data. It included information on like the people who run their project, the plans for individual engineers, which is obviously very sensitive data, and then of course information on their defects they found. Obviously, all that sort of thing would be very sensitive and things that companies would be very concerned about. The trust obviously is with the SCI to protect all that data, and we are also a part of that uh, um, absolute protection of data privacy. So the data that we received as it was released from the SCI has been sanitized, and by that I would say that as an example, the name of every individual, the name of every project, the name of every component, the name of every task, the name of every process, the name of every process step, the name of every, like all the details about defects. Everything has been run through a one-way hash and turned into kind of a string of gibberish. So you can now see that there's an individual whose name is like XYZ592 or something. And that you can see what projects that person was on, et cetera. But tracking back to a specific individual is impossible. And the same with the projects, with the components, the teams, the organizations, et cetera, that submitted data. Now you might ask, well, if it's been so thoroughly scrubbed where any human readable text has basically been turned into gibberish, is how can we even analyze it? I mean, and the important thing to understand is that the shape of the data is still there. And so even though we can't track this back to a particular organization that submitted it or a particular real world project or a particular real person, you can still see that there was a team that had 7 people on it that ran like a series of, say, 5 project increments that found this many defects and this many components, et cetera. And you can look at that data and you can compare it from one team to another, et cetera. So the data that we will receive in the future will go through the same standardization process. And the fact that data from uh, thousands of people and hundreds of organizations has all been put into a single database makes it virtually impossible to track any one piece of data back to um, the, the individual project team or organization that contributed it.
Wow, that sounded like it was a big job to sanitize all that data. So back to Bill. Bill, you've been doing research for decades now, and I know you've done a lot of research at the Software Engineering Institute. I know you did a lot of research as a nuclear scientist, building nuclear reactors for submarines and aircraft carriers. What makes this data set different? Like how can researchers use it differently than the typical data sets that are out there, and why does that matter?
Well, one of the big problems we have in software engineering is, in fact, the definitions of what you're measured. They can vary so much from one instance to the next. And by using the team software process, we do put a few very clear stakes in the ground. And these things are well defined. And each of the organizations has to define a process. So you're actually not seeing just the outputs, you're seeing the step-by-step work. All of these things that Jeff described in the measures put within the context of a process framework. So you're actually seeing work evolve as it's being produced, not just the outputs at the end. And yeah, today you might be able to see some outputs, or maybe you can go and do some resource mining in a repository, but you're getting bits and pieces of the snapshots. This gives you a sort of coherent view that simply is not otherwise available. So I think it really is unique. That's not too strong a word here.
And so Robert Bentel, Robert's also on the panel today, and he's representing that industry perspective. So, Robert, how can industry use this team? How can teams use that? Why is this data valuable to them? Is Robert here?
Unmute?
No, he's not muted. I see him at the end of the list. Oh, went away. He became forward.
Yeah. I'll tell you what, we'll give Robert a second to he's there's been some Zoom issues today. And Steve, I think there was a question in the chat. Um, so would you like to ask that question?
Yeah, there was one question in the chat of whether we plan to have a discussion group such as a Discord or a mailing list. And there's already a reply in the chat, which is we do have an online forum that serves this purpose, and it's at our softwareexcellencealliance.org website. And there's a join the discussion portion. So softwareexcellencealliance.org/deepsea, DEEPSEA. And that is a forum for exactly this kind of collaboration. That was one question. Another question in the chat was there any collaboration with the isbsg.org who collects similar data? And I'm not sure if one of the panelists has that answer.
I can tell you there was no collaboration with the icebergs folks. And our data is fundamentally different from icebergs. The icebergs, ice bags, they fall under the category if you get some outputs, some outcomes. They have some contextual data and some other things, but you don't really have the process at a granular level. They do occasionally have some process at the aggregate level in totals, but you don't get to actually see work flowing through the system.
Interesting. Interesting. Um, so, unfortunately, Robert is really having a lot of Zoom problems, but I'm going to go back to Bill and David then and talk about, what kind of questions, whether it's benchmarking or research, can be answered with this data. So what questions can you answer? I'll start with Bill.
Yep.
Sorry.
Well, I think David gave some examples. The kinds of things you could ask are testing certain things on conventional wisdom. What do people actually do rather than what they say? What sizes are the teams really in the wild? How does performance vary by things like the team size, or how do they organize? The things like team size is often more of a tactical matter of how you're structuring a larger project. You can get a lot of information on things like benchmarking uh, with some caveats, but you can understand things like where are people actually spending effort? What are the different activities? We've got an entire value stream, and we put a lot of emphasis on coding. But when you look at it, we had a lot of benchmark data that said that was maybe 20% of the effort. I'm sure it varies by domain. How much? It's a useful question. So you can actually look at what do the data really tell you about the way things are operating, and how could that shift the kinds of questions that you think are important to ask?
Awesome. One of the questions in the chat was about whether or not the C would be releasing the PSP individual educational data, and that data is already available through IEEE. Bill, can you speak to that very quickly?
Absolutely. Anyone who wants that data can have it. It is on the IEEE data port. Uh, if there's a need for a link to that, just send me an email and I'll send it back, or we'll put something in the DeepSea discussion boards. But that has been released under the Creative Commons as well.
Okay.
I'll go
Unfortunately,
back
so
to,
oh,
and I also wanted to tag on to the question that you'd asked about benchmarking and research questions. So one of the things that I'd like to point out is that as a community, the TSP community, we've done some really, really amazing analyses with data. I mean, you compare the things that we do on just a regular garden variety project, the way we analyze data, the way we use it to manage quality and schedule, et cetera, is just top tier. And I look back on this wonderful history of data use within our community, And I see that one of the maybe biggest missed opportunities is that we've rarely analyzed data at anything larger than the scope of a single project. And so one of the reasons is that we just obviously we didn't really have data at our fingertips to do that. Our tools did allow us to capture data for a single project and provided some great reports for that. But we've never really had the opportunity to really do some project analyses. The only people that had that data were the SEI. And so now the exciting thing is that everyone in the world has that data and everyone has the opportunity to start doing these, whatever sort of not just cross project, but cross team, cross organization, like global analysis that you're interested in. It used to be that the SCI was the only organization that could look in and crunch the numbers and say that 200 lines of code seems to be the break even, 200 lines of code per hour seem to be the break even point for, like for code reviews for getting good yields. And so now anybody can do that sort of analysis and it can be based on real data. I mean, there's a lot of other really exciting things that I think we can do, but that's basically my biggest takeaway.
Yeah, so just building on that, one of the things that Jeff talked about in his presentation was how you can use the data to augment planning to help you make better plans. David, can you speak to that? We're hoping to throw that to Rob, but if you could speak to that, that'd be wonderful.
Sure. I mean, one of the most obvious reasons that we use data to make better plans is to make better estimates. Like, for example, if we have historical data, we can use that historical data as like evidence-based rationale for making better estimates. And that certainly falls in line here. But I think there are a lot of other great opportunities as well. I look at the data and I see things like as a TSP community, for example, we have gotten some great measurements on the like the relative percentage of the work week that teams spend on their backlog versus on coordination and collaboration. And that's a metric that's pretty not very well known within the larger engineering community, but it's one that we track pretty closely. So I think it would be fascinating for us to look in and see, well, how does that vary? Does it vary significantly from team to team or from person to person or even from week to week? Like could be that a single individual, I want to say, Bill did some analyses and he showed that the amount of time that a single individual on a team can devote to the backlog can vary from like 25% covariance from week to week, which
That was the whole team.
and that's the whole team. Even when you correct all of the variances within a single individual, and so that certainly is going to affect your velocity, especially if you've got 2-week sprints. And so our tools need to understand that variability and help us to plan for it. And I think just being able to mine the data and understand what that variability is would be a great example of how we could basically make better forecasts. But also looking at things like the estimating errors, we've got plan versus actual data now for tens of thousands of components. And so we can understand within that data set what sort of biases are common in teams when estimating, what sort of range of estimating errors occur. And if a team doesn't have their own historical data on those numbers, a tool could always pull from this data warehouse data set and use it as a starting point for the variability and uncertainty that's present in a team's plan. So those are just some examples.
And just to build on that a little, even if you can't reliably look at any particular piece of data or an average, you can look at what the ranges are. You can look at the sensitivities. How are your results going to be sensitive to the choices you make?
I can tell you anecdotally, we find that engineers tend to overestimate how much time they have available by 50%. So when they build their plans, they're usually 50% behind schedule before they even start because they think they have twice as much time available than they actually have. All right, I'm going to ask a question from the chat, and feel free anybody to answer it. So how is this data warehouse, how can it be utilized for software, hardware? Can EMD, production, manufacturing, quality control, use it to meet production outcome?
I can jump in, and if unless you'd like to talk to it, Bill, but
And
one of the
Brad
things that
can as well, because I know he works with a lot of those types of teams as well. But go ahead, David.
And I'll just chime in. I think, the question is about general scenarios for using the data. So David has already talked a little bit about, if you're planning, this is how it might be useful, but I think there's other scenarios as well. So I think if we talk about some of those topics, it'll also indirectly address this question.
Thank you.
one of the things that the community has found is that the principles behind TSP work exceptionally well for any kind of knowledge work, whether it's software or systems engineering hardware. And one of the things that you'll find is when you look into the warehouse is that some of the size metrics in there are hardware components or cables or chips or boards. And so there were hardware teams that were collecting data, and they are represented in this data set. So some of the things that we find is that when it comes to defect injection rates or estimating errors or schedule variances, a lot of those things often tend to track back to human fallibility. And so we end up seeing the same sorts of estimating errors or defect rates in different types of work, whether it be hardware or software. And so there's a lot of cross domain applicability for the data, but I think it's also great that the hardware is represented in this data set.
Thank you, David. I know that I myself, in some of the data that I uploaded in working with different teams, were using size measures like, developing presentations or pages or developing models. Bill, did you want to build on that?
Yeah, I don't see Jim Over here in the list today, but I'll tell one of his stories. One of the organizations he was working with, the the software team actually got so good that they were hitting their dates better than the hardware team that were building circuit boards. And they ended up finding that just estimating the number of pins that are going to be on the boards was a good enough proxy to to be usable for improving their estimation performance. So yeah, there have been other examples similar to that where this does it's a very general purpose application. It is not software specific.
So, another question in the chat, what new data is in the sea that might be used to discover impactful patterns? I'm going to throw this one to Bill because I know that you have, just in preliminarily looking
Mhm.
at the data, been able to see some impactful patterns in terms of like, optimal near-term planning horizons. Can you speak to that a little bit?
Well, I would say that first of all, predicting what's going to be high impactful is kind of speculative. But but just last month, I did do a presentation where we took some of our TSP data and basically we converted it into simulated ticket type data for Jira. And we were able to look at questions of, if we discretized this information in Jira tickets and we lost certain types of things that TSP calculates, how does that change our view? And what are some of the biases? And we found some interesting things. And one of the first things that I discovered quite quickly is the way they analyze things like story velocity right now has some fundamental problems with truncation and censoring that have never been addressed. Well, if you want to know how many sprints you need to get in your rolling average, well, you could simulate that with our data and get a pretty good estimate.
So, Bill, what would be, what would the researcher need to know before like drawing casual conclusions from the data? Like, what are some caveats that you would have for researchers using the data?
Or
Well, you
causal,
certainly
or causal
casual and
conclusions.
causal, yep. Yeah, you certainly need to understand what are the potential biases from using this data? Uh, One of them would be, these were taken by TSP teams. They were typically not extraordinary individual performances. That's something that we don't really believe in. But as a team and an organization, they had enough team discipline to be using the process. We know they had enough organizational support to be using it. So there's going to be some selection bias there. Uh, I think the commitment to that is probably key. The other thing to be aware of is this is observational data. So observational data is hard to use directly for causal analysis. There are some caveats and some techniques, but you have to be very cautious about that. More likely, you want to use the observational data to get a good working hypothesis. And I think the big thing is there's still some missing context. I had a bunch of data where I broke these organizations into things like their business domain. We had some information on organizational size and so forth. Unfortunately, when IT did a laptop rebuild, they failed to back up my database folder. So I have to see if I can find that in one of my backups. If not, that's going to have to be some future work to rebuild some of that. I had some other things too, like a mapping of how teams were related, how the individual projects were related in sort of like super cycles, how they build into larger projects. That's contextual data that we would like to get out at some point, but it's non-trivial. Over.
So David, I don't think anybody's closer to the data than you are. Would you have some caveats in using this data set, data warehouse?
My advice would be that since this is data that's collected by real teams, real projects, it varies based on the team and the project that was collecting it. So um, sometimes the data may be dirty or incomplete, and that's something you need to be on the lookout for. For example, there would be some teams that faithfully collected the actual size of their products as they finished, and other teams that wasn't important, so they didn't capture it as faithfully. And so if you're going to do an analysis that relies on actual size, for example, you would want to do a pre-filter to make sure that you are finding teams that collected the data you need to answer your hypothesis first before you start your analysis. But I would say that almost all teams in the warehouse did a very good job of estimating and collecting planned and actual time, since earned value is a pretty key central part of PSP. And so analyses that are based on those on that realm are pretty safe to do across the entire data set.
So Bill, follow up.
Yeah, I did a paper on that at ICSSP with Yaz back in the mid-teens. So we could also give you a link to that article. It gives you some ways you can analyze the quality of the data, and it gives a bunch of things you can look for, indications of missing data, indications of what kind of data is just totally missing, those sorts of things. So that's a known problem, and we have some known ways to look at them.
So one of the questions just came in with the chat is, do you plan to maintain a database of questions people ask? And I'll open that to anyone on the panel.
That sounds like a great suggestion. I know that the questions that are asked today will be posted on DeepSea along with the answers. And we welcome anyone in the future who's watching this presentation later on YouTube, for example. If you have a question, click the join the discussion link and post it. And the members of the data warehouse team monitor that forum, and we will answer your question. And so this doesn't have to be just an hour-long presentation, but it can be an ongoing dialogue. And DeepSea is a great way to have those conversations.
Well, David, I think that actually sounds like just a really interesting thing the data warehouse should, continue. Like, how are we going to publicize or, maintain a repository of analyses people do and how they use that data? What are some of the other, things that you see in the future for the data warehouse?
I think definitely one of our very first next steps would be to uh, finalize the process for accepting new data. The data that we've released so far is the data that the SCI collected during the period of time that they were managing that project, that program. We would like to begin accepting submissions from teams that are still actively using PSP and teams that have collected data in the years since the SCI stopped gathering it, and grow the data set in that way. As Bill mentioned, there's some additional metadata and context that we would love to add to the warehouse, like which industry domain a particular team is most closely associated with, so that you could filter the projects by, say, hardware or software or medical devices or et cetera. And of course, that comes with its own set of data privacy concerns. And so it's something that we would have to approach very carefully to make sure that we still maintain the anonymity of the organizations that contribute data. One of the other things that I would love to do, teams, as they collected data, defined their own processes and workflows that they would use for doing the work. And unfortunately, that's one of the things that's not present in the warehouse as it is today, because the workflows themselves could sometimes be identifying. So the names of the workflows or the steps in them might have made it possible to track it back to a particular team, project, or organization. And so those have been scrubbed for now. We would love to find a way uh, to overcome that and maybe release some of the process structures so that teams that are interested in analyzing different workflows and different types of, of attacking a problem would have that data, that contextual process data to look at. So that's something that we would love to add in the future. As Jim mentioned, and as Bill mentioned, the PSP data is out there and available on IEEE, and so I think it would be an excellent addition to be able to pull in that data and have it as a section of the in the warehouse for analysis as well. And then, of course, the most of the data that's in the warehouse right now was collected using the process dashboard, because that's because we have extraction, transformation, and loading logic for that data to load it into the warehouse. But definitely looking to the future, we will look into supporting import from other tools to include things like Jira, Azure DevOps, et cetera.
So, Bill, you have a follow-up?
Yeah, just to clarify, although we aren't exposing the individual workflows that were being described, the individual work, we do have the older TSP dashboards had some idiosyncratic process flows separate from the dashboard workflow. And we have essentially a grand unified scheme that subsumes all of these different variants. So we do capture the idiosyncrasies between the particular high-level workflows as described as a TSP process.
That's a
Okay.
good point. And so for example, it is possible in the warehouse to do an analysis and see how much time was spent in high-level design, how much time was spent in requirements, how much time was spent in an inspection versus building of the product. How much time was spent in appraisal versus failure. All those things can be determined. The analyses would be done using the steps in the TSP framework as opposed to the steps in an individual team's custom workflow.
And as long as you trust my mapping, I've done the hard work. So all of the data in the warehouse has some comparability that way.
Great.
Thank you. All right, so I just want to kind of wrap up today and really encourage everybody to, take advantage of this warehouse. We're not going to just throw the data over the wall. If you want to use it, whether it's for research or for, in your projects, we can help you analyze that data. It's not like you're just going to get it. We'll be available to assist with use of the data. And, I've seen so many great ideas in the chat. There's another one like of sharing articles and things that have been written as a result of using the data. So, we're not stopping here. We're continuing to go and build on this. We encourage everybody to consider submitting data. I mean, I think that's the one thing that is unique about the Software Excellence Alliance is how much we use and rely on data to augment engineering judgment, because sometimes engineering judgment is wrong. So I want to thank the panel and I want to thank everybody on the data warehouse for all the hard work that they've done to make this warehouse available. So everyone, please join me in a round of applause for them. I hope everyone takes advantage of it.